I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic Aperture Antennas for the course Transmission Lines and Antennas. So, aperture antennas. An antenna with an aperture at the end can be termed as an aperture antenna. Waveguide is an example of aperture antenna. The edge of the transmission line, when terminated with an opening, radiates electromagnetic energy. The term aperture refers to opening in a closed surface, make it an aperture antenna. So there are various types of aperture antennas. One is the waveguide antenna, horn antenna and the slot antenna. So now the waveguide antenna, a waveguide is capable of radiating energy when excited at one end and open at the other end. The radiation in a waveguide is greater than a two-wire transmission line. The operational frequency range of a waveguide is around 300 MHz to 300 GHz, and the antenna works in ultra high frequency and extended high frequency ranges. So the limitation of waveguide is the waveguide with terminated end act as an antenna, but only a small portion of the energy is radiated while a large portion of it gets reflected back in the open circuit. It means the voltage standing wave ratio value increases, the diffraction around the waveguide provides poor radiation and non-directive radiation pattern. The radiation of a waveguide antenna is poor and the pattern is non-directive, which means omnidirectional. And next is the horn antenna. To improve the radiation efficiency and directivity of the beam, the waveguide is provided with an extended aperture to make the abrupt discontinuity of the wave into the gradual transformation, so that all the energy in the forward direction get radiated. This can be termed as flaring. So now this can be done using a horn antenna. The energy of the beam, when slowly transformed into radiation, the losses are reduced and the focusing of the beam improves. A horn antenna may be considered as a flared out waveguide, by which the directivity is improved and the diffraction is reduced. Advantages of this horn antenna are it provides moderate directivity, low standing wave ratio, broader bandwidth and simple in construction. A horn antenna is used to transmit radio waves from waveguide out into space or collect radio waves into waveguide for reception. It typically consists of short length of rectangular or cylindrical metal tube, that is the waveguide, closed at open one end, flaring into an open-ended conical or pyramidal shaped horn on the other end. And horns are widely used as antenna at ultra high frequency and microwave frequencies above 300 MHz. They are used as feed antennas called feed horns for larger antenna structures such as parabolic reflector antennas. And now a very important case to discuss for horn antenna is Huygens principle. So Huygens principle, which states that every point on a wavefront may be considered and a source of secondary spherical wavelets which spread out in the forward direction at the speed of light. A principle by which actual sources such as antenna and transmitter are replaced by equivalent source. So types of horn antenna, we have a sectoral horn. There are two types, E-plane sectoral horn, H-plane sectoral horn. This is based on the flaring direction. If the flaring is done in the E direction, that is vertical direction, it is called as E-plane sectoral horn. If the flaring is done in the horizontal direction, that is it is called as H-plane sectoral horn. And if flaring is done in both E and H directions, it is called as pyramidal horn. And the third type is circular horn. If the waveguide used is a circular waveguide, and the horn is called as circular horn. And in circular horn there are two types. One is conical horn and biconical horn. And the types of horn antenna we discussed, and the advantages are small minor lobes, impedance matching is good, greater directivity, narrower beam width, standing waves are avoided. But there are some disadvantages. It is the designing of flare angle decides the directivity, and flare angle and length of the flare should not be very small. And application of horn antenna, it is a microwave antenna. It also used as a feed element for radio astronomy communication dishes and satellite tracking. And another type of antenna is aperture antenna, is a slot antenna, and a rectangular slot is made on the conducting sheet. So these slot antennas can be formed by simply making a cut on the surface where they mounted on. And advanced applications of slot antenna, usually used for radar navigational purpose, used as an array fed by a waveguide. Assessment: which of the following type does horn antenna belongs? It is a aperture antenna. The answer is C. And which of the following antenna mainly used for broadband signals? The answer is the horn antenna. Thank you.